Okay, so let's take a look at number 1. Um, we've got a table. It says that the table above contains function values along the graph of a quintic polynomial function h of x. So we know that this is a 5th degree polynomial. It also says that the only zeros of h of x are zeros specifically listed in the table. So let's focus on those specific zeros. All right, so I'm only finding 2. It says, which of the statements that follow is or are true about h of x? Well, let's take a look at number 1. It says x plus 3 is a factor of h of x twice. So we know that x equals -3, so the factor is x plus 3. Let's take a look at the y values. Well, I've got a negative y value on the left, and I've got a negative y value on the right. So let's just take a look at what that would look like. This is our thinking process. Well, if you have a multiplicity of 2, that's going to have that bounce, right? It's going to be tangent to the x-axis, which means the y is positive on both sides of that, or the y is negative. So basically the y values are going to be the same sign if you have a multiplicity of 2. So if I take a look at that, I would agree that that is correct because we've got negatives on both sides. So that would imply that there is some sort of bounce going on. Now let's take a look at number 2. It says the multiplicity of x equals 1. So we know that this is a multiplicity of 2. It says cannot be determined, but it must be a 1 or 3. Well, if we take a look at that, to the left and to the right, we know that it's cutting through. We know that the y value is negative on this side. It cuts through, and then it's positive on this side. And that would indicate mostly a multiplicity of 1 or 3. However, it can't be 1 because remember that we have a quintic and these are the only zeros. So if this one has a multiplicity of 2, this one must have a multiplicity of 3 because they have to add to 5. So that means number 2 is not right. All right, so that means I can cross off the ideas that have 2 in them. Now let's take a look at number 3. If A is a leading coefficient, okay, remember that a leading coefficient determines the end behavior. So if A is the leading coefficient of the equation, then the A is negative. A is less than 0. So that means I'm going to look at the right side of the graph. Well, that's positive, which would tell me that my A is positive. And so that means this is false also. So 3 and 3. So that means my only answer is going to be A. All right, so let's take a look at number 2. It says find the value of k so that x plus 3 is a factor. All right, so in order for that to be a factor, I know my remainder must be 0. So there's a couple of ways to do this. I showed in the polynomial unit that we could utilize synthetic division, and we've practiced that. So this would be a 3, this would be a -2, this would be at k, and this would be a -3. And then remember though, when you're doing this process, you've got to add down 33 plus k times -3 is going to be -99 minus 3k. And when you add these together, which I'm going to do right now, so I've got -3k minus 102. Remember that if it's a factor, this remainder needs to equal 0. All right, so if I take a look at that, -3k minus 102 needs to equal 0. -3k is equal to positive 102. Divide by -3, divide by -3. I'm going to get k is equal to a negative. And then let me look at my answer. Okay, they're looking for the values. 3 goes into 10 3 times with 1 left over, so that would give me negative 34. So in this case, D would be the answer for that. And then 3, what can be said about the value of P of 1 and the remainder when P of X is divided by X minus 1? Well, if you were to evaluate P of 1, and if you were to synthetically divide by 1, because if that's the factor, X minus 1, the 0 is 1, the number that you get when you evaluate is going to equal the remainder of this polynomial. So P of 1 is going to be equal to the remainder. You could do that, but the whole point of the remainder theorem is that entire idea that if you were to evaluate, it is the same result as if you were to synthetically divide and you get the same remainder. Let's take a look at 4. It says, how many times is X minus 1 a factor of this function? Well, in order for me to do that, I'm going to go ahead and divide. And so I'm going to use synthetic division. So I've got 1, negative 3, 5, and negative 2. Get this out of the way. And then I'm going to divide by 1, right? X equals 1. And so here I'm just performing my synthetic division, but this is where some people go wrong. First of all, we guarantee that we did our right work because we got a 0 for the remainder. But take a look at this. If this was x to the 4th, then that means this is x cubed, and then this is x squared, and that this is x. So basically, my new equation is 1x cubed plus 0x squared minus 3x plus 2. Well, I need to synthetically divide by 1 again. I already know it's a factor once because I got a remainder of 0, but now I need to do it again. And now I need to check to see if I get another 0 here. So I get negative 2. Look at that. I got another 0. So this is now x squared plus x minus 2. So that's my new equation. It's already happened again. So now I know it's at least twice because I got a remainder of 0, but I need to do it again. So let's just see up until how many times it takes me. So this is 2 and this is 2. Oh, look at that. I got a 0 again. So that's 3 times. All right. So this becomes x, and that's just, so 1x plus 2. Let me just divide it again just to make sure, just so you can see what it's going to look like. And so right here, this is my remainder of 3, so that is not a factor. So this happened to have a multiplicity of 3. So the correct answer is D. All right, number 5, it says, which of the following binomials are factors of the polynomial function f of x? Well, there's a couple of ways to do that. We could do synthetic division. And so, or you can evaluate. So either you could go f of 1, which means x is 1, x is negative 1, or x is 3. So you could either evaluate. Sometimes if you evaluate, you taking the chance that you might mess up on the order of operations, but it's absolutely up to you. So you could do it this method, or you can synthetically divide. So let's do x minus 2, not x, but 1 minus 2 minus 11 plus 12, making sure that that's in standard form, which it is. So let's just go ahead and do this really quickly. I know that this is 1. I'm going to get a 1 here, negative 1, negative 1, negative 12, negative 12, 0. So I know that this is a factor because I got a remainder of 0. Now I'm going to try negative 1. So I'm just going to erase my work right here. So I've got negative 1, I got negative 3. I've got 3, I've got negative 8, And then I've got 8, and so that's not going to work. And then now let's go ahead and take a look at what if I were to do 3. And so I'm going to get 3, I'm going to get positive 1, a 3, a negative 8, a negative 24, and that's not going to help me out here. So it looks like I only have a for 5. Number 6, if f of x and x minus 1 is a factor, what would the function be? What would the function be written in completely factored form? Okay, so the cool thing about this is we can synthetically divide, right? So let me make some room over here. We already know that when we synthetically divide by 1, our remainder is going to be a 0. So I'm going to get here, I'm just going to make sure that I'm doing my work correctly, which I am because I got 0, so that's good. So we know completely factored form is x minus 1 because that gave us a 0. But remember now, if I started with cubed, that means this is going to be an x squared and then an x. So I've got 1x squared minus 2x minus 15. So one of two things can happen. I can go ahead and factor this. I can utilize my answer choices to maybe figure it out. But I already know that the two numbers that multiply to negative 15 and add to negative 2 are x minus 5 and x plus 3. But you could totally factor by grouping, but the bottom line is you're going to get x minus 5 and x plus 3. So I'm looking for the answer that has x minus 1, x minus 5, and x plus 3. So that looks like D is going to be our answer here. Let's take a look at 7. The graph to the right is a polynomial function with a relative maximum at the point negative 1, 4, and relative minimums at the points negative 4, 0, and 2, negative 2. Which of the following statements is or are true? The graph changes concavity at x equals negative 4. That is not true, simply because a graph is going to change concavity if it's at the inflection point. Okay, inflection point is based off of one of 3 conditions. One is that it's got a multiplicity of 3. The other one is it's the midpoint between the 0 and a max or min. And then the other one is the midpoint between max and mins. All right, so you can go back to your notes. It talks about the three conditions on which an inflection point occurs. So that doesn't change concavity at negative 4. What that does is it's tangent. So automatically number 1 is out. So we can eliminate those 3 answer choices. All right, so let's take a look at 2. The graph has an absolute minimum at point 2, negative 2. Well, that's absolutely the lowest point on the graph, so that is an absolute minimum y value. So 2 is good, which means 3 only isn't going to work. So my answer choice for 7 is A. But let's go ahead and take a look at 3. It says if C is the constant term in the equation, then C is a value between 2 and 3. Well, what do you know about the C value? Well, the C value is the constant, which is the y-intercept. So if I take a look at the y-intercept is between 2 and 3. So that is a true statement. So that's, again, another way to validate that A is our proper choice. All right, let's take a look at number 8. It says, which of the following statements is or are true about the polynomial graph below if all of the zeros of the function are real zeros? All right, so we've got the negative root has a multiplicity of 2. Well, if they're talking about roots, then let's go ahead and identify them. So it looks like we have a root at x equals negative 3, and we should be able to identify the multiplicity of that as a 3. And then we also have x is equal to positive 3, and it looks like it just goes straight through there. It doesn't change concavity at all, so it's a multiplicity of 1. So that looks like all of the zeros, and it even says right here, all of the zeros are real. So let's take a look. The negative root has a multiplicity of 2. Well, we know that that can't be true. Multiplicity of 2 is going to be where it bounces back, or in vocabulary words, it's going to be tangent to the x-axis, and that is not true. It's actually an inflection point. Number 2 says the function is a quartic. So is it x to the 4th power? Let's take a look. If we were to add up all of our multiplicities, we can definitely see that it is going to be a 4th power polynomial. And we can even double check that by looking at the end behaviors. They're the same, so it should be an even degree. All right, so we know that 1 is not going to be a solution. So now we're looking at C or D. So we know that 2 works. Let's take a look. The positive root has a multiplicity of 1. Oh, look at that. So our positive 3 has a multiplicity of 1, which we've already established. So then that is also true. So C is the correct answer for that. Number 9, the graph of g of x is pictured at the right. For what values is the function greater than 0? Please notice that it does not say equal to. Okay, doesn't say equal to. It says, where is it positive? So it's going to be positive. That's an open circle, and that's an open circle. So if I were to color code this, it's going to be, well, wrong color here. It's going to be positive on this interval. So it cannot include the 0 because it doesn't say equal to. So I'm going to go from negative infinity all the way to -2, but not include -2, pick back up on the other side of -2 and go to 1. And so that means I'm looking at answer choice C. All right, number 10, which of the following statements are true? Number 1, g of x is less than or equal to 0, which means it's negative or equal to 0. So it's equal to 0 here, here, negative, and here. All right, so on the interval from 1 to 3, okay, and it's bracket, so it's including that, and x equals -4. And that's true because it's equal to on that. So I would say that 1 is correct. So let's get rid of all the ones that don't contain a 1. Okay, so the rest of them contain a 1. Now let's take a look at 2. X plus 3 is a factor 1 time. So let's take a look at -3. It's not even a 0, and so that's not going to be true. So let's get rid of the ones that have a number 2 in it. And then the leading coefficient of g of x is negative. Well, remember, the leading coefficient determines the right side of the graph. So the leading coefficient is not negative, it's positive. So the only one that's true is A. All right, and then it says, oh, we're supposed to use this graph 10 through 12. All right, so on which of the following intervals of x is g of x increasing? So that means when we read it left to right, where is it going up? So it's increasing from here to here and then from here to here. Remember, if it's increasing, never, never, never brackets. It's always going to be parentheses. But let's just take a look. We know that it's not negative infinity to -4. We did not draw that. It looks like we're going from -4 to -1. From -1 to 2 is decreasing, so that's not right. And then from 2 to infinity is also increasing. So we're looking for 2 and 4. So that means we're looking at E. 12, which of the following statements are true about the graph of g of x? So the graph is decreasing on the entire interval from -1 to 2. So let's take a look. Where is it decreasing? From -1 to 2. That's not the only place, but it is going to be decreasing on this entire interval. It's not the only place, but it doesn't say that's the only place. It just says the graph is decreasing on this entire interval. That's true. The graph of g of x has 2 points of inflection. So now we need to go back over here and remember where the inflection points are. Inflection points are where there's a 0 with multiplicity of 3. So that's not the case. The inflection point is going to be between a max and min, the midpoint. So there's one inflection point. Here's another inflection point. And then the other inflection point is, well, that was one from the 0 to a max or a min. That's one statement. And then max and min. And so there's only 2 inflection points. So 2 points of inflection. So that is also true. The domain is all real numbers. Well, let's take a look. Is there a whole? Is there every x value that's represented? That's true. Polynomials are all real numbers. So we're looking at 12 as being E. Which of the following are solutions on the interval to this inequality below? All right, the nice thing about this, guys, is it's already factored for you. So now we just need to find out what our zeros are. All right, so our zeros are, we've got x is equal to 0, x is equal to -2 twice, x is equal to 3, and x is equal to 6. So let's draw our number line. We've got a 0 here, we've got a -2 over here, we've got a 3, and we've got a 6. So those are where we're drawing our number line here. All right. So let's see, we've got 1, 2, 3, 4, 5 factors. All right, so we've got, and don't forget about that negative right there. So we've got 1, 2, 3, 4, 5, and then a negative. Okay, we've got, I'm running out of room for here on this one. 1, 2, 3, 4, 5, and then a negative. 1, 2, 3, 4, 5, and then a negative, and then 1, 2, 3, 4, 5, and the negative. Now you could apply that to -x, but I didn't do that. I just made the x value whatever we pick, and then we'll just count that negative. 1, 2, 3, 4, 5. All right, so let's go ahead and pick. Let me pick -3, a -1. Let's pick a +2. Let's pick a +4, and let's pick a +7. And so now I'm just going to go ahead. X is, and again, this is a -3. So x is -3. X plus 2, -3 plus 2 is going to be a negative twice because of that. X, -3 minus 3 is a negative, and then a -3 minus 6 is still going to be a negative. So I've got 1, 2, 3, 4, 5, 6. So this is going to be a positive right here on this interval. Now let's go -1. So I've got a negative here. -1 is going to be a positive twice, a negative here, and a negative here. So I've got 1, 2, 3, 4 negatives. All right, so let's take a look at 2. I've got a positive twice, a negative, and a negative. So that means I've got a positive. And then I've got, oh wait, I forgot about that other negative here. 1, 2, 3. So 1, 2, 3. This one's a negative. That should be a negative. Forgot about that leading negative here. Let's do a 4. So this is a positive. This is a positive twice. 4 minus 3 is positive. 4 minus 6 is negative. So it looks like I have 2 negatives, which make it a positive. Let's take a look at 7. So I've got a positive here, positive twice, a positive, and a positive. Overall, that's going to give me a negative because of that leading guy. All right, so now that I've established that, let's take a look. Where is it greater than 0? In other words, where is it positive? So I am positive from negative infinity to here. Also from here to here. It doesn't say equal, so I can't include those. Each time I have to have an open circle. All right, so from negative infinity to negative 2. So that interval right here is not right because of the fact that it includes negative 2, and that's not okay. This interval from 3 to 6, notice that it's not brackets. So from 3 to 6 is positive, and then from 6 to infinity is not true. So we are looking at Roman numeral 2 only. So 13 is C. All right, last multiple choice. Which of the following statements is true about this? X minus 4, which tells us that x is equal to 4, is a factor twice. So x is equal to 4 is right here. It's not even a 0. So that's not true. Now, negative 4 is a factor twice, but that's not what the factor is. All right. X equals negative 4, which means the factor would be x plus 4. The equation of h of x has a negative leading coefficient. Remember, the negative leading coefficient tells me that I'm falling to the right, so that's true. And the graph has 3 points of inflection. So let's go ahead and count those. So at negative 4, that is not an inflection point. That is tangent to the x-axis. Inflection points are the midpoints between max and mins. So there's one right here. Here's another minimum and a maximum. So here is another inflection point. And then I do not also see where it changes concavity in terms of like that chill anywhere on the graph. So we've got 2 points of inflection. Let's see, and let's see, B, 2, and 3. So let's see if we can find another point of inflection. Oh, I missed that one right here. Look at that. A minimum and then a maximum. So this guy right here is going to be an inflection point. So inflection point right here, that makes the third one. So just really quickly, the definitions, I don't see a chill, but the definitions are going to be between max and mins. So here's a minimum and a maximum, and it's the halfway point. Here's a max and a min, and here's the halfway point. Here's a minimum and a maximum, and there's the halfway point. So there's 3 points of inflection. So that is also right. So 2 and 3. So 1 was not an option. And then B would be our final result for 14. We're going to talk about the free response question on A. The directions say picture to the right is the graph of a polynomial function g of x and use the graph to answer the question. So on A it says identify the zeros and then their multiplicities and then explain specifically how you know the multiplicity of each zero. So we need to get better at our academic vocabulary. So no chill, no bounce, and stuff like that. So let's try to learn the correct way to explain something in mathematical terms. So we can definitely see a lot of you guys were able to identify the zeros of the function. And we know that negative 3 is a multiplicity of 3, not because of the chill, but because the graph crosses the x-axis and it changes concavity. All right, and then that's what gives us that different type of shape right there. And then x equals 2 has a multiplicity of 2, not because of the bounce, but because the graph is tangent to the x-axis, which means it's only touching once at that spot. All right, now on B, it says, will the leading coefficient of the equation be positive or negative? So not only do you have to say that, but you have to give a reason based on the end behaviors and the degree. So your answers need to have those conditions in them. So, and we don't want to, I gave you guys credit if you said like falling to the right, but that's not what we want to be able to say. We want to be able to look and use the notation to justify our mathematical responses. So the leading coefficient is negative because the degree is odd. You already know that it's negative because it's falling, but we're not going to use the word falling. So the leading coefficient of negative is because the degree is odd. Okay, it's opposite, right? So the degree is odd, and as x approaches negative infinity, in other words, you're describing the end behavior on the left. As x approaches negative infinity, g of x is approaching infinity. And as x approaches infinity, which is down here, g of x is approaching negative infinity. And this is the proper notation to indicate like falling. Okay, so we want to be able to utilize that mathematical language. All right, then it says on C, it says identify x coordinates of the points of inflection and give a reason for each of your answers. So some of you gave me ordered pairs. Well, I only want the x coordinates. So let's take a look at our x coordinates. So, well, the first one is x is equal to -3. And the reason that's a point of inflection is it's because it's a 0 with multiplicity of 3. All right, so we've already established that it was a multiplicity of 3 up in A because it changes concavity. So when you are justifying this, we know that -3 is a point of inflection because it's a 0 with multiplicity of 3. The next one is going to be, according to the conditions, if you have a 0 with multiplicity of 3 and either a max or a min immediately following that, the approximate point of inflection is going to be based on the midpoint. So -1.5 because it's the midpoint, and again, only the x coordinate. -1.5 because it's the midpoint of a 0 with a multiplicity of 3 and a minimum. Okay. Then the last condition says, hey, the other point of inflection is when you have a minimum and a maximum consecutively, then the point of inflection is right there in the middle. So we took the x values. So you're adding up the x values and dividing it by 2. So x equals 1 because it is the midpoint of the max and the min. All right, now let's do D. It says identify each of the following intervals. On your test, I only asked you where it was concave down. And so when it's concave down, you need to look at this component of concave down. There's two types. This is concave down, but increasing. And then this one is concave down but decreasing. So if it looks like any type of this type of curve, then it's going to be concave down. So let's take a look. From here to here, this is concave up. Okay, concave up. It looks like the part of a cup. Remember that at the multiplicity at 3, it changes concavity. Okay, remember, but only to the halfway point. So this part right here is going to be concave down. And again, it's going to change concavity because we said that that was the inflection point. And then we've got here is the other inflection point. So it's important to notice where your inflection points are. Here, here, and here. So that means we've got to be able to identify where there's a change in concavity. So that means here to here. All right, so at each of those points where those black lines are, you're changing colors of concavity. The green represents concave up, okay, and the purple represents concave down. So we are going to be from, and again, this is never brackets, it's going to be from -3 to what we said the x value was -1.5. So on that interval, and then from the interval from 1 to infinity. Okay. And so let's just put that up here. We have from -3 to -1.5, and then from 1 to infinity.